Good evening, everybody. I'm Karthik, Assistant Professor, Mechanical Engineering Department from SNS College of Technology. This is a case study about failure of a helical gear. First, before going to the case study, we are going to see the following contents: introduction, case study, experimental procedure, result and discussion, and conclusion. In failure, the introduction is about the failure analysis of a helical gear, which is used in a gearbox. The history is that this gear has been used for 3 years, and the material which is used is AISI 8620ST, and the evaluation methods are visual inspection, photo documentations, chemical analysis, micro hardness measurements, and metallography. Okay. The below 6 types are the failure types that is happened in gears which is employed in the high speed machines. The first one is fatigue, second one is impact, third one is fracture, fourth one is wear, fifth one is stress rupture, and the last one is surface contact fatigue, which is pitting and spalling. Okay, so the next thing is that the causes are poor design of gear sets, misalignment of gears, overloads, subsurface defects in internal areas, and use of incorrect material and heat treatment. Here the case study is that the bus with a problem with its gearbox, the gearbox running hot with excessive vibrations. The problem was with the 4th speed drive gears. See, this is the general appearance of the gear. You can see some of the cracks which is seen here. Next, we are going to see the parameters. The first one is that in helical gear there are 36 teeth, 15-degree helical angle, module is 4 mm, pitch circle diameter is 150, and the outer diameter is 158 mm, and the face width is 42 mm. In spectrum analysis and micro hardness, it is revealed that it is an AISI 8620 carbide steel. And the core hardness of 439 HV, the HV is nothing but Vickers hardness, and the surface hardness of 550 HV, and the case depth is 0.63 millimeter. Here the microstructure consists of martensite and retained arsenate. So this is the microstructure where these white colors are nothing but the arsenate, and the black colors are nothing but the retained martensites. So the white is retained arsenates and the black color are martensites. So in visual inspection, there are a number of adjacent sheets are failed due to fatigue, and the triangular piece of the teeth has been broken off as I showed earlier. The crack initiation and benchmarks can be seen through naked eye, and the origin of crack was at the pitch line, and there is no corrosion media found in the fracture area. So this is the photograph of the failed structure where you can see this arrow mark indicates the starting point of the crack, and you can see some fatigue striations it is found, and the crack which is and the pieces which is broken, it's in a triangle area. So in next one is that in pitting, the destructive pitting and spalling were also noted at the loaded area of each tooth, and the destructive pitting area appears as much larger pits than initial pitting. In spallings, pits are large in diameter and quite shallow. In spalling is caused by the excessive high contact stress, which is predominantly seen in high speed machines. So here these are the photographs. In this we can see the destructive pittings and the spallings which is seen in the micrographs. So in same with the scanning under microscope and EDX examination, it is revealed that it is caused due to the fatigue cracks initiation and propagation, which can be confounded by seeing the river-like patterns seen in the propagation zone. EDX is attached to the fracture surface to determine the gear geometry to verify the presence of any associated components for the cause of this failure. So here you can see this is the same image where you can see this river-like markings, and this is the crack initiation area. Conclusion is that The composition microsection hardness is found satisfactory, but factorography indicates that the fatigue is the main failure cause, which is predominantly occurs on the high-speed machines. Misalignment were observed, which is also a cause of failure. Formation of destructive pitting and spalling at one end due to the load concentration on that particular area. And so, as I said earlier, the fatigue is the major cause of these types of failures in the high-speed machines. Thank you. That's all for today. Have a great day.